Welcome to all. Our next objective is to design the cam profile when follower motion is prescribed. The follower motion can be prescribed in analytical form, that is y as a function of theta, or in graphical form, that is y versus theta curve. So this is y, this is theta, this is rise period, then dual, then return, then another 12. So this is theta equal to theta ri. So when y is given or prescribed, then how to design the cam profile? So before designing the cam profile, we have to determine some basic dimensions of cam profile. So determination of basic dimensions of cam profile. We know that the size of the cam depends on base circle radius, that is RB. RB is the base circle radius. Now the objective of the designer will be to choose a minimum value of RB, because if we choose a small value of RB, then the cam profile will be very compact. But we cannot choose RB arbitrarily. So there is a minimum value of RB which is required. So we have to determine the minimum value of RB. We have to determine also value of offset. Offset is desirable to us. When cam is rotating in counterclockwise direction, that is in this direction, then the offset from the cam center in right hand direction is considered as positive. We need a offset in right hand direction because this offset reduce the value of pressure angle. So what is the minimum value of offset required for a cam profile? So our objective is to design or is to determine the minimum value of RB, the minimum value of offset. Now this analysis, we'll do this analysis for translating follower. Translating flat face follower. First one, we'll do this analysis for translating follower, and first we'll consider a flat face follower. So number A is flat face follower. This is a flat face follower, and epsilon is the eccentricity of driving effort. Epsilon is eccentricity of driving effort, and here C is the contact point between follower and the cam. So this is the cam profile, this is the cam profile, and this is the follower. So C is the contact between cam profile and follower, and this distance, that is the distance of C from the axis of the follower, is epsilon, which is called eccentricity of driving effort. But there is a allowable value of eccentricity. So there is a allowable value of eccentricity, and epsilon max, that is maximum value of eccentricity of driving effort, should be less than epsilon allowable. Why we cannot take it as large as possible? Because if epsilon is long or epsilon is a large, then this is the common normal. This is the common normal between cam profile and flat face follower. So cam will push the follower along this direction. So this will create a moment to the follower, which will tend to rotate the follower within this guide, and that will make cause of jamming of the follower. So there is a allowable value of epsilon, that is maximum possible value of epsilon, that is epsilon max. So this has to be prescribed here. So this will be given. So what is maximum allowable value of eccentricity of driving effort? That will be given here. Now let us come to what is the value of minimum base circle radius for the cam profile. The value of minimum base circle radius depends on, that is a function of rho, where rho is radius of curvature of cam profile. Rho is radius of curvature of cam profile. So for cam profile is always convex. That is, rho is always greater than 0. Rho cannot be negative. But why we need a minimum value of rho? Because the contact stress depends on the value of rho. That is, if say this is the follower, if this is the flat face follower and this is the cam profile, so here a contact stress will be developed. The rho for follower is infinity. If rho value for cam profile is very less, then contact stress will be high. So there is a minimum value of rho which is prescribed for the cam profile, and that depends on the contact stress. Here the value of rho mean will be given. So value of rho mean also be given. So let us note the inputs to design or to determine the basic dimensions of a translating flat face follower. Here we are talking about translating flat face follower. That is, y of theta is given. These are the input. So rho mean, that is minimum radius of curvature of the cam profile, that is also given. Rho mean is given, and epsilon max, that is maximum eccentricity of the driving effort. These three parameters are prescribed or given. So these three are prescribed. So these three are given to design the cam profile, and our objective is to determine what is RB mean, that is what is minimum required value of base circle radius, and what is the required minimum eccentricity. So this is a flat face follower where C is the contact point. C is the contact point between follower and cam, and this is the base circle radius. This is the base circle radius. RB is the base circle radius. So RB is the base circle radius. So this is base circle radius, which is denoted by RB. O2 is the cam center here. Now this is the point S. So point S, this is point S. So point S is what? It is the point where cam profile touches the base circle. So where cam profile touches the base circle, that is the point S here. So it is obvious that the minimum height of the follower, this is the follower, minimum height of the follower when S was vertical, that is S was on this line. S was on this line, that is the base circle, that is the red circle defines, that is this, if we draw a tangent, horizontal tangent to the base circle, horizontal is, that is parallel to the flat face. So this is the horizontal tangent to the base circle. So when S, that is the point where cam profile touches the base circle, when S was here at the vertical point, at the vertical level, then the height of the follower was minimum, that is the shortest distance of the follower from the cam center O2. So here at this level y was 0, y equal to 0. Now cam is rotating in counterclockwise direction, and here at this instant this is the y. So this is denoted by y theta, any y, that is y of theta. So we can say that this rotation, that is S was here, say S was S prime. So S prime to cam rotates to S by this rotation, that is theta. Here this rotation is theta. So due to theta rotation, the corresponding displacement of the follower is y of theta. So due to this theta rotation, this is the theta rotation, it is mentioned here, this is theta rotation. Due to this theta rotation in counterclockwise direction, the corresponding displacement of the follower is y of theta. Now C is point of contact between cam profile and the follower, and at point of contact the radius of curvature of the cam profile is rho. So rho is radius of curvature at radius of curvature of cam profile, curvature of cam profile at point of contact C. So rho is the radius of curvature, this is the rho, this is rho, and this point is OC, this point is OC, this is OC. So OC is the center of the curvature, OC is center of the curvature. As this is the OC is the center of the curvature, so for small increment of cam rotations, so for small increment of cam rotations, O2, OC, this is O2, cam center, OC is the center of the curvature, and C C is the point of contact. These 3 points are fixed. Fixed for what? For small increment of cam rotation. That is for very small rotation of the cams. These 3 points are fixed points. As these 3 points are fixed, then we can say what? We can say theta. This angle is theta cam rotation plus psi. This is psi. This angle is psi. This angle is mentioned psi. So theta plus psi is constant for small increments of cam rotation. So we get psi plus theta is equal to constant. That is psi equal to a constant minus theta. That is d psi by d theta is equal to minus 1. So d psi by d theta is minus 1. Now what is the expression of rho? Rho is radius of curvature of cam profile at point of contact C. So this is rho. So rho equal to OCC. That is equal to y of theta, this amount, y of theta. This to this is RB, this is RB, this is RB. So plus RB plus this amount. Now this total angle is psi. This total angle is psi. So this angle, this remaining angle will be psi minus pi by 2. Psi minus pi by 2. So this amount, that is this vertical distance, will be O2 OC sine of this angle, that is psi minus pi by 2. So rho becomes y of theta plus RB, and this becomes minus O2 OC cos of psi. So what is y of theta? Y of theta is rho minus RB plus O2 OC cos of psi. Now let us derivate y in respective of theta. That is y prime theta. Y prime theta is dy by d theta. That is equal to, these two are constant, so gives 0, O2 C minus sin psi into d psi d theta. That is y prime theta becomes d psi d theta is minus 1, so that becomes O2 OC sine of psi. Then what is second derivative of y? That is y double prime theta. That becomes O2 OC cos psi d psi d theta is minus 1. So minus cos psi. So now here, if we come to here, that is, or better here, if we come to here, this quantity, that is minus O2 OC cos psi, is y double prime theta. So we can write the expression of rho from this. Say this is equation 1 and this is equation 2. So if we put the value of this value here, if we rearrange these two equations, then what we will get? We will get rho equal to RB plus y of theta plus y of theta, and this is y double prime theta plus y double prime theta. Now let us come to this page that we got what? Rho. Expression of rho is RB plus y of theta plus y double prime theta. Now value of rho depends on this function, that is rho will be minimum, so rho will be minimum when this quantity is minimum, that is plus y of theta plus y double prime theta, this is minimum. So now from this we can get the minimum value of base circle radius, that is RB mean. RB mean is rho mean minus y of theta plus y double prime theta mean. So this is the expression for minimum base circle radius, that is RB mean. Now let us find what is the minimum required value of offset, that is E mean. E is the offset. So let us find what is the minimum required value of offset, that is E mean. So what is E plus epsilon? E plus epsilon is this distance, O2, say O2B. So E plus epsilon, that is equal to O2B, which is nothing but O2 OC cos of this angle was psi minus this angle was psi minus pi by 2. This angle was psi minus pi by 2. So psi minus pi by 2. That is E plus epsilon. E plus epsilon is what? That is O2 OC sin psi. Now what is O2 OC sin psi? Let us come to here. We get that O2 OC sin psi is y prime theta from this equation. So from this equation we get E plus epsilon is y prime theta. So epsilon becomes y prime theta minus E. So permissible value or maximum value of epsilon, that is epsilon max. Epsilon depends on this parameter y prime theta. So epsilon max will be what? Y prime theta max minus E. So from this equation we get the expression of minimum required E, that is minimum value of E that is required for the cam follower mechanism. E mean is what? Y prime theta max minus epsilon max. So this is the minimum required value of eccentricity, E mean. So this is the expression for E mean, and this was the expression for RB mean. Now our next objective is to determine the required minimum follower width. This is the follower width. What is the minimum follower width required to maintain the contact? So this is B follower width. Now let us determine what is minimum follower width to maintain the contact. So this is B. Now let us take a reference that is from follower axis. Follower axis is our reference. So here x equal to 0. Now we have noted that E plus epsilon, that is equal to y prime theta. That is, epsilon is y prime theta minus E. Let us consider that epsilon in right hand direction is positive and epsilon in left hand direction is negative. That is the value of x. X is positive along this direction and negative along this direction. So here point of contact is at C. So if B is less than this distance, say if we take B up to this, then the contact between follower and the cam will never maintain. So we need at least greater than C here for this instant. Now epsilon will be maximum. When epsilon will be maximum? In right hand direction, that is epsilon max in positive direction, that is, let me denote it in different way. Epsilon positive, that is in right hand direction, maximum is what? Y prime theta max minus E. It is obvious that when y prime theta greater than E, then only epsilon will be right hand direction. Similar way, when y dot theta is minimum, then epsilon will be in left hand direction. So that is, epsilon in negative direction in left hand side, that is left hand side, when it is minimum, when it is negative, that maximum negative value will be what? Y dot theta minimum plus E, because if this is my datum, then in this direction E will be plus. So minimum follower width required, that is B mean, minimum follower width required, that is what? Epsilon positive max, that is in right hand side, plus epsilon negative max, maximum negative value, and mod of that, obviously we take the value only, not the sign, plus some allowance in both direction. A is allowance in each side. We need some allowance, not exactly that, we'll take some greater value, that is, say this is here allowance here for this instant. So plus A. So B mean, minimum width of the follower, is epsilon max is y prime theta max minus E plus y prime theta mean plus E, mod of this, obviously mod of this, plus 2A. Now E cancelled, so we get that, let me write down it here, B mean is what? Y of theta, y prime theta max plus y prime theta mean, mod of this, only the value, plus 2A, that is the allowance. So this expression gives the minimum required value of the follower width. Now let us solve a problem that has been asked in GATE 2020. A cam with translating flat face follower is desired to have the following motion. So y of theta, expression of y of theta is given, that is analytical form is given, and range of theta is also given, that is theta varies from 0 to 2 pi, that is for complete cam rotation, complete cycle of cam rotation, expression of y is this one, that is given. Context trace considerations dictate that the radius of curvature is rho of the cam profile should not be less than 40 mm anywhere. That is, minimum value of radius of curvature is given, that is 40 mm. That is, should not be less than 40 mm. So minimum value of rho. The minimum permissible base circle radius is to be determined. That is, we have to determine what is RB mean. What is the value of RB mean? We know that the expression of RB mean we have just derived, that is rho mean minus y of theta plus y double prime theta minimum. So expression of y of theta is given. So what is y prime theta? Y prime theta, this is 8 pi theta, that means 8 pi minus 4 theta square, that is 8 of theta. Then what is 8 y double prime theta? That is minus 8. So y double prime theta is minus 8. So we can write it, RB mean is rho mean minus y of theta is 8 pi theta minus 4 theta square minus 8 minimum of this value. That is y double prime theta is a constant. Now y of theta, this term will be minimum when theta equal to 0 and theta equal to 2 pi. That is, at theta equal to 0 and theta equal to 2 pi, y is 0. That this expression satisfy that. If we put theta equal to 0, that y equal to 0, y becomes 0. If we put theta equal to 2 pi, then also y equal to 0. So minimum value of this term, that is y theta, is 0. So the minimum value of this expression is nothing but minus 8. So we can write the value of rho mean is 8 minus of minus 8, that is 48 mm. So the minimum permissible base circle radius is 48 mm. So this is the answer to the problem. Now let us determine the basic dimensions for translating roller follower. This is a cam follower mechanism with roller follower, and we know that during rise period, the maximum value of pressure angle must be less than 30 degree. That is, value of phi max must be less than 30 degree during rise. Otherwise, there will be a tendency of jamming the follower in the sliding. So value of phi must be less than 30 degrees. So let us first determine the expression of phi. What is phi? So in this cam follower mechanism, fixed link is 1, cam is 2. This is the cam profile. This is the cam profile. This is cam profile. This circle, that is this circle is called base circle. That is the smallest circle tangential to cam profile and center at cam center O2. So this is point O2. Now this curve is called what? This curve is called pitch curve. So this is pitch curve. This curve is pitch curve. And this circle, that is this circle is called what? Prime circle. Prime circle is the smallest circle tangential to the pitch curve and center at cam center O2. and this is the trace point T, that is at the roller center. This is trace point. Now this is the common normal at point of contact between roller and cam. This is the common normal, and we know that the angle between common normal and direction of follower translation or follower movement is called pressure angle. So this angle is phi. This angle is phi. Now from here, so if say this point is B and this point is A, and center, roller center, say this is T. Say roller center is T. T is the trace point. T and C are the same point, that is the roller center. So what is expression of tan phi? That is tan of phi is AB by AC. That is that we can write O2B minus O2A divided by AC. What is, now let us calculate what is O2B, and we know that O2A is nothing but E. O2A is E. Now to calculate O2B, we'll take the help of Arenholt-Kennedy's theorem. We'll take the help of Arenholt-Kennedy's theorem of 3 center. So here fixed link is 1, cam is 2, roller is 3, and follower is 4. So how many relative instantaneous center will be there? That is 4C2, that is 6. And what are the relative ICs? That is I12, I13, I14, I23, I24, and I34. So these 6 are the relative ICs. Now O2, that is the revolute pair which connects link 1 and 2. So O2 is nothing but I12. O2 is I12. So we have located I12. Where is I14? So this fixed link is 1 and 4 is the follower. So there is a prismatic pair between 1 and 4. This fixed link is 1. So for prismatic pair, the I14 will be at infinity. So at infinity, this is I14, and the direction is perpendicular to the sliding direction. So this is the location of I14. So we can also consider that I14 also lies on this line. These two are parallel. So this is at infinity I14. I14 lies on this line also, which is perpendicular to the, this is perpendicular to the direction of sliding. Now where is I23? Where is I23? 2 is the cam and 3 is the roller, and roller has roller rolls as well as slides over the cam. So I23 will lie on the common normal. That is, this is the common normal. Common normal at point of contact. So we can say that I23 lies on this line. That is the common normal. Now where is I34? 3 and 4 are connected by this revolute pair at T or C. So C is nothing but I34. Now we are interested to locate I24 to calculate the value of O2B. So where is I24? Let us locate I24, and to locate I24 we will take the help of Arenholt-Kennedy's theorem. So first we will take link number 2, 1 and 4. 2 and 4 are common. So I12, I, I12, I14 and I24 are collinear according to Aronhold-Kennedy's theorem. Where is I12? O2 is I12, that is, this is I12, this point is I12. I14 lies on this line, so I24 must lies on this line. So I24 lies on this line. I24 lies on this line. Now next we'll take, this is one set, and in next we'll take, sorry, we'll take next set is 2, 3 and 4. Link 2, 3 and 4, and we can say that I23, I34 and I24 are collinear. Now these three are collinear. Where is I23? I23 we know that lies on this line. I23 lies on the common normal. And this is I34. This is I34. See, that is roller center. So I24 also lies on the common normal. So I24 lies on this line as well as on this line. So intersection of this, that is point B. Point B here is the location of I24. So point B is the location of I24. Now let us draw it into a fresh diagram here. What we have done, this is the common normal. So this was B, that is I24. This point was A, this is O2, this point is C, and this angle is phi. So what is tan of phi? Tan of phi, we know that AB divided by AC. AB is nothing but, we have already calculated, O2B minus O2A divided by AC, divided by AC. So first let us calculate what is O2B. To calculate that, we have to use the fundamental of relative IC, that B is nothing but I124. So velocity of body 2 at I24, we know that velocity of body 4 at I24. So what is velocity of body 2 at I24? Body 2 has a pure rotation about O2, that is the cam, and if angular velocity of body 2 is omega, then omega into O2b, B is I24, that is equal to velocity of body 4 at I24. And we know that this is body 4, that is the follower which has a pure translation. So all point on body 4 has same velocity, and velocity of body 4 is what? Dy by dt. This is the velocity. Now what is omega? Omega is d theta, theta is cam rotation, divided by dt into O2b is dy by dt. That implies O2b, O2b is what? Dy by d theta, that is y prime theta. So we have calculated the value of O2b, and O2a is nothing but E, that is the offset, value of offset. Now the remaining task is to determine what is AC, value of AC. Now we have to understand that what is the lowest position of the follower in translating roller follower. So the this circle is the prime circle. This circle is the prime circle, and the trace point by which the motion of the follower is measured, this is the trace point, that is the center of the roller, that cannot go below the prime circle. So the lowest position of the follower is this point, that is the intersection of prime circle and axis of the follower. So this point, say this point is S prime. So this point is S prime, and that denotes the lowest position of the follower, and we can say that set that at y equal to 0 at this height, and this distance is y of theta. Theta is corresponding cam rotation. Now at this instant, what is the theta value of theta? We can look at here that at this point, say this is point S, this is point S. S is the point where the pitch circle, this is the pitch circle touches the prime circle. So when the point S was here, that is at S prime, then y was 0. So at this location, when S was at S prime, y was 0. Now S comes to here and y becomes y of theta, and cam is rotating in counterclockwise direction. So this is the corresponding theta. So due to this theta, the follower displacement is y of theta. So this height, that is C to S prime, is y of theta. Now what is O to S prime? O to S prime, this is nothing but RP. RP is the radius of the prime circle. So this is RP. This is RP. RP is radius of the prime circle. And what is this height? O to A. O to A is nothing but E. So now our objective is to determine AC. What is AC? AC is AS prime plus CS prime. What is AS prime? This height, that is O2S square minus O2S prime square minus O2A square, that is RP square minus E square. By Pythagoras theorem, this height will be square of this height minus square of this height, and CS prime is nothing but plus y of theta. So now we get all the values. So tan of phi, that is O2B is y prime theta. O2A is nothing but E divided by root over RP square minus E square plus y of theta. So we got the value, that is tan of phi. Please note it, tan of phi is equal to y prime theta plus minus E y prime theta minus E divided by root over RP square minus E square plus y of theta. So this is the expression of pressure angle. And for cam follower mechanism, during rise phase, phi must be less than 30 degree. And with these two, we are going to calculate what is the minimum value of base circle radius, RV mean, the value of RV mean, and value of minimum offset. And we will do it by graphical method here. The expression of pressure angle, that is tan of phi is equal to y prime theta minus E divided by RP square minus E square plus y of theta. Now y of theta is a periodic function. That is, in every 2 pi rotation y will repeat. So this is a periodic function. For any periodic function, if you draw the graph of y of theta versus y prime theta, the curve will be a closed curve. Whatever may be the shape, but the curve must be a closed one. So this is a closed curve. Now, so this is y prime theta versus y theta versus y prime theta curve. That will be a closed curve for any, if y theta is a periodic function, then this curve will be a closed curve irrespective of shape of the profile. Now let us draw a line. Let us draw a line, and this distance is E. This distance is E. This is O. Center origin of the graph is O. Now from O, draw a arc with radius RP, and that cuts this line at C. So this is RP. OC is RP. OC is equal to RP. Now say any point on the curve, that is this point A, corresponding to theta, that is A is corresponding to theta, and if we join AC, A to C, if we join A to C, then what is this angle? What is the value of this angle? This angle will be always phi, that this angle represents the pressure angle at corresponding to theta location. That is, let me show how this is phi. If this is phi, then what is tan of phi? Tan of phi is, say this point is B, that is AB by AC. What is AB? This coordinate, that is y theta coordinate of point A is y dot theta, and this length is E, so y dot theta minus E. Now what is, I'm very sorry, tan of theta will be AB, this is the perpendicular, by base, that is BC. Now what is BC? This height, say this point is D, that is CD plus DP. What is CB? That is tan of phi is y prime theta minus E. What is CD? CD is root over RP square minus E square. And what is DB? DB is nothing but y theta coordinate, that is plus y of theta. So these two expressions are same. This is same with the expression we got for pressure angle. So what is the conclusion? That if we take any point A that is corresponding to theta rotation of the cam, and if we join A to C, then the inclination of AC with the vertical line, this is the vertical line, gives the pressure angle, that is the phi. Now with this concept we can determine RB minimum and E minimum. How to do that? That is, for a given cam displacement diagram, that is if y theta is given, y theta is given for any cam rotation, y theta is given. So if y theta is given, then we can determine y prime theta. So we can easily draw the curve, that red curve, that is y theta versus y prime theta. In translating roller follower, we know that the maximum value of pressure angle should not exceed 30 degree. That is, phi max is less than 30 degree during rise phase. Otherwise, there will be a tendency of jamming the follower inside the guide. So when y theta is prescribed, we can easily find y prime theta. So we can plot the graph. This red line shows the plot, that is y theta versus y prime theta. Now, which part of this graph shows rise phase? If we consider that left hand side of the plot, that is left hand side from this vertical line, this is left hand side. Here y prime theta is positive. That is, this is during rise phase. We know that during rise phase velocity of the follower is positive. And in right hand side from this vertical diagram, from this vertical line, that is we can see y prime theta is negative. So that indicates return phase of the follower motion, where velocity of the follower is negative. So for the left hand side of the plot, that is left hand side of the plot, phi should not exceed 30 degree. That is, phi max must be less than 30 degree. To maintain that, what we can do, that we can draw a line which makes 30 degree to the vertical, and that just touch the left hand portion of the curve, that is this line. We have drawn a line. Now say this is point A, any point A that correspond to cam rotation theta, then this angle is 30 degree. This is vertical line, so this angle is 30 degree. That means pressure angle at point A is 30 degree. Next, what we can do, from this point, that is the origin O, we'll draw another line. That makes 30 degree to the vertical. That is, if this is the vertical line, then this angle is also 30 degree. Now here the intersection between these 2 points is C. This point is C. Now if we draw a vertical line from C, that is this vertical line, this is the vertical line from C, then this distance is nothing but E mean. Our objective was to determine RB mean and E mean. So this distance we have determined that this is E mean. If say this point is B, then OB equal to E mean. And we know that OC is RB, that is prime circle radius, so RP mean. Now what will be RB mean? RB mean is RB mean is RP mean minus RR. RR is the roller radius. RR is the roller radius. That will be prescribed. Roller radius will be given. Now how this construction satisfy that E mean and RP mean? Because in this construction let us consider any point on this red curve which is left hand to this red vertical line, left hand to this line. That any point, if we join any point, say this is any point x, if we join x to C or any other point on this curve, that will make below 30 degree to the vertical. That satisfy that phi max should not, phi max is less than 30 degree. Here phi is max, that is at point A phi is max and that is equal to 30 degree. Or any other point, say x, there phi is less than 30 degree. Now if we consider right hand side, right hand part of from this red line, there's any point, say this is the point. If we join this point to C, that this point is y, that also makes less than 30 degree to the vertical. If this angle is, say this angle is psi, say this angle is psi, then psi must be less than 30 degree. Any other point will make less than 30 degree to the vertical if we join that point to C. And OC is the minimum value of the prime circle radius. So from where we can determine the minimum value of the base circle radius, that is RB mean is RP mean minus RR, where RR is the roller radius. So this is the way to design the basic dimensions of a translating roller follower. Now let us solve a problem. A disk cam with translating roller follower is to be designed such that the displacement of the follower, that is given y theta is prescribed, that is 15 1 minus cos 2 theta. The base circle radius is to be 28 mm, that is RB. Value of RB is given, value of RB is 28 mm. Roller radius is also given, roller radius is 12 mm. Offset to the right side, that is positive offset for counterclockwise rotation, offset is 3 mm. It is also mentioned that cam is rotate counterclockwise, that this offset is positive offset. For cam rotation, theta equal to 30 degree, determine the pressure angle. That is, what is the value of phi? Phi has to be determined. We know that what is the expression of phi? Tan of phi is y prime theta minus e root over rp square minus e square plus y of theta. So RB is given, then what will be RP prime circle radius? RB plus RR. So 28 plus 12, that is 40 mm. Now let us find what is y of theta at theta equal to 30 degree. That is 15 1 minus cos 60 degree. Cos 60 is half, that is 15 into half is 7.5. 7.5. What is y prime theta? What will be y prime theta? That is 30 sine 2 theta. So y prime theta at theta equal to 30 degree, that is 30 into sine 60 degree, that is root over 3 by 2, that is 15 root 3. 15 root 3. Now let us find the value of phi corresponding to theta equal to 30 degree. So what is y prime theta? Y prime theta is 15 root 3 minus 3, 15 root 3 minus 3. RP is 40 mm, so 40 square. E is 3 mm, that is 3 square, plus y of theta is 7.5. Now let us calculate. You will get value of the phi is 25.86 degree. So this is the value of pressure angle for corresponding to cam rotation 30 degree. Now our next objective is to design the cam profile in graphical method. First of all, we'll do it for translating flat face follower. As this is a graphical method, so y theta will be given. Y versus theta graph will be given. This is theta, this is y. This is rise, then dual, then return, then another dual. So this is theta equal to 2 pi. That is a complete rotation. Up to this is theta Ri for rise. This is theta dual 1. This is theta Re return, and here theta d2. So this displacement diagram is given, and for translating flat face follower we have already determined the value of minimum base circle radius and value of minimum offset. So RB and E we have determined earlier, and now y theta plot is given. In this situation, how to draw the cam profile for flat face follower, translating flat face follower? What we shall do first? We'll draw the RB. That is, let us first do the base circle. So this is the base circle. This is the base circle of the cam, that is RB, and cam center is O2. If the cam rotates in counterclockwise direction, then offset has to be provided in right hand side. So let us first draw the follower axis. So this line shows the follower axis. This line shows the follower axis, which is at distance E from the cam center. So this is E or E mean. So this value is E mean. Now, as this is the base circle and face of the follower for flat face follower, that is horizontal. Face of the follower is horizontal. So minimum height of the follower represents by this horizontal line, which is tangent to the base circle. So this line represents the minimum height of the follower. That is at here y equal to 0. Y equal to 0. Now what we shall do? We will transfer this y theta curve here. That is, this is y, and we shall transfer this y theta graph here. Now let us divide the rise phase. I am drawing only for the rise phase. Say divide it into 4 equal parts. You can divide it into more parts, then accuracy will be more, but it will take more time. And let them call it 0, 1, 2, 3 and 4. Station points 0, 1, 2, 3, 4. And the corresponding y here, this is the position which corresponds to 0. This is for theta equal to 0. Say this is theta equal to 0, then theta 1, then theta 2, then theta 3, then theta 4. So first theta is 0, at 1 theta equal to theta 1, at 2 theta equal to theta 2, theta equal to theta 3, and theta equal to theta 4. So corresponding y at point 0 is nothing but this point, because this is the lowest level of the follower. Now let us project this y to here. These are the corresponding y to the cam rotations. and here. So these are the points. Let them call it. This is also 0, this is 1, this is 2, this is 3, and this is 4. Now the axis of the follower, the red line, let me draw it with a red line. This is the axis of the follower, which is always tangent to the circle, which is called offset circle. What is offset circle? Offset circle is the circle which has center at O2 and radius E. If we draw the circle here, center at O2 and radius E, this circle is called offset circle. And axis of the follower is always tangent to offset circle. So here, now to draw the cam profile, we have to make a kinematic inversion. What is kinematic inversion? That in cam follower mechanism, this is the fixed link on which follower moves, that is on which follower translates, and cam rotates in counterclockwise direction. To get the same kinematics, what we will do? We'll fix the cam, that is we have fixed the cam, and rotate the follower axis, or this guide, rotate the follower axis opposite to the cam rotation with same angular speed. That is, we will rotate this follower axis in clockwise direction with same angular speed to the cam. Now if we rotate this by theta 1, as this angle is theta 1, here this is theta 1, say theta 1 is this angle, so this radius will come to here, that is we have rotated it in clockwise direction. So tangent to this circle here at this point, this is the tangent to that. Similarly this will be, so this is theta 2, here this is theta 2 rotated by theta 2 in clockwise, and this is the tangent. So this is theta 3 and this is the tangent. Now the distance of the follower from cam center at station point 2 is nothing but this one, 2. So 2 to, if we, sorry, first for 1, so let me draw it, remove it. So corresponding to theta 1, the distance of the follower from O2 is this one. If we join 1 to O2, this distance. Now with this radius at center O2, we'll draw an arc, and that cuts the corresponding line here. And at this point, follower face is perpendicular to this line. So we'll draw the perpendicular to this line at this point. So this is the this line represents the follower face. Similarly, for station point 2, this is the distance. So radius at O22 will draw another arc, and that cuts the corresponding tangent here. So, and follower face is here is perpendicular to the tangent, this blue line. Similarly, for station point 3, we'll draw another arc from with radius O23, and that cuts the corresponding tangent here, and the follower face will be perpendicular to this, perpendicular to the tangent. Now we get 4 follower faces. This is for 0, this is for 1, this is for 2, this is for 3. Now cam profile is nothing but an envelope to the family of these straight lines. That is, now let me draw the cam profile. What is the cam profile? If we draw the cam profile, that is, this one is the cam profile. So cam profile is nothing but, let me draw it once again. So this green line is the cam profile, that is envelope to the family of the straight lines. And that envelope is always, and these straight lines, that is follower faces, are always tangent to this envelope. So this is cam profile is the envelope to the family of straight lines, that is this straight line which shows the follower face, here this straight line, here this straight line. So this is the process to draw the cam profile in graphical method. We can continue for all other points, that is for station point 4, 5, 6, and you can take another points here. So that should be continued to get the complete cam profile, but this is the process. So we have done this for flat face follower. Now let us see how to draw the cam profile for translating roller follower. Similarly, here also the y theta plot will be given. This is the theta, this is y. So this is theta equal to 2 pi. So y versus theta is given. And for roller follower, RP mean and E mean and RR, that is the radius of the roller, is given. RP mean is the minimum prime circle radius. So here we shall draw the prime circle radius first. We shall draw the prime circle first, that is cam center is at O2 and RP is the prime circle radius. So this is the prime circle of the cam profile, and this is RP. Cam is rotating in counterclockwise direction. Cam is rotating in counterclockwise rotation. As E mean is given, and E mean is positive when cam is rotating in counterclockwise direction, that is in right hand side from this line. So here this is the follower axis, that is this distance is E. So this is E, value of offset. Now for roller follower, if this is the prime circle L, then intersection between follower axis, that this is follower axis, this is the fixed link, this is the fixed guide. The intersection between follower axis and prime circle is the minimum height of the follower. So this is the corresponding minimum height of the follower. So from this level we can say that at this level y equal to 0. Similarly here also we'll shift the y theta curve. This y theta curve will shift to here. Say I am drawing only for the rise phase. We'll divide it. Say here we are dividing it into three equal divisions, 1, 2 and 3. You can take more divisions, then accuracy will be more. Now here also we will draw the same offset circle, as this follower axis is tangent to the offset circle. So this is the offset circle. This is the offset circle. Now if cam is rotating in counterclockwise direction, to get the same kinematics, the inversion will be what? We will rotate the follower axis with same angular velocity of the cam in clockwise direction, that this is the clockwise direction. So if this is corresponding theta 1, this is theta 2, this is theta 3 and this is 0, then we will rotate the follower axis by angle theta 1. How to do that? We will rotate this line by theta 1. This is theta 1. this is theta 1 in clockwise direction, and from this point we will draw a tangent to the offset circle. This is the tangent. Next we will rotate it by theta 2, this is by amount theta 2, and we shall draw the tangent. Similarly, this is theta 3 and we shall draw the tangent. Now we will project these heights, that corresponding y, that is this is y1, to the follower axis. So this is corresponding to 1, 2, 3, and this point is corresponding to 0. Now when 1 is here, the height y1 is here, the actual position is y, that is distance of 1 from O2 is this one. So we'll draw an arc with radius O2 to 1, and that cuts this corresponding tangent here. Next we'll draw an arc with radius O2 2, and that cuts the corresponding tangent here. Similarly, we'll draw another arc to O2 3, and that cuts the corresponding tangent here. So these small circles are nothing but the center of the roller. So now let us draw the rollers. As RR, that is roller radius, is given, so we can draw the roller here. As center, we have got the location of the center, so we can draw the rollers. Now for roller follower, the cam profile is the envelope to the family of these circles. The circles which shows the rollers, that is this circle. Sorry. This circle. So this is the cam profile. So here cam profile is the envelope to the family of circles. Circles, that circles means these rollers. These are the circles. These are the 4 circles drawn by the green color, and this green line shows the envelope to this family of these circles, and that is nothing but the cam profile. So we have designed the cam profile for translating roller follower by graphical method. Now we are ending our session here. Thank you.